So, hello everyone, this is lecture 18 for electricity and magnetism. In the last lecture, we were discussing the motion of charged particle in the magnetic field. We already discussed the motion in the electric field. Now, today we will discuss the motion of charged particle in the uniform electric and magnetic field. So, first case we will discuss that electric and magnetic field is perpendicular to each other. Electric field in the z cap direction and the magnetic field in the x cap direction. So, total force on the charged particle will be given by QE due to electric field and QV cross P due to the magnetic field. So, this will be your complete force. Now see, this is your kind of system, means the particle will be released at the origin at rest. Then what kind of motion it will have, that's what we will see. So when it is released, charge particle is released at the origin. So initially the velocity is 0, so there will be no magnetic force on this, so magnetic force will be 0, but only electric field, and that electric field will give the motion in this way. Now when the particle is starting motion, then it will have some velocity, so it will also observe the magnetic force when it starts moving. Then you will see that the particles means magnetic force will start it rotating, and electric field is accelerating it in this way. So as the speed is increasing, magnetic force is also increasing, and that magnetic force is in the direction, means V is in here and B is here, so V cross B will give you force in this direction. Here it will be in this direction, here will be in this direction, so magnetic force will be like this. So at this point magnetic force will be in this way, and maximum means at one point this magnetic force will cancel out the total electric force, so the particle will be in this way and in the maximum velocity. Now the particle will, means the magnetic force is largest, so it is make it move like this. Now the magnetic field is in the opposite direction to the electric field, so this electric field will decelerate the particle, means now as the particle moving this way, so electric field is in this way, so this force will start decelerating the particle, and as the speed decrease, the magnetic field or the magnetic force will start decreasing, and as it will reach, means as the speed decreases and the speed becomes 0 at this point, so magnetic force will be 0 and again it will force the electric force. So this situation will be again back to the square one. So just like particle was here, it will be again here, and it will again observe the same force and it will move like this. So the motion will be something like this, and this path is called cycloidal path, and this motion will be cycloidal motion. So this kind of motion the particle will have in the yz plane. Now this motion will be restricted in the yz plane perpendicular to B. So must remember this, charged particle will be confined in a plane perpendicular to B. So this is your plane perpendicular to B. So charged particle will remain in this region only. Now see, we need to solve this equation. To find, now we have to find the how y is changing with z. So we need to find the equation for this curve. So for that we need to solve this equation. And now to solve this equation we need some initial conditions. So at origin the coordinates y0 and z0 is 0. So at t equal to 0 y is 0, at z t equal to 0 is 0. Now speed is also 0 y and z at this point. So because we have released it in the rest. So y dot 0 is 0, z dot 0 is 0. So we'll use these initial conditions to find the motion. So let's see, speed at any point is given by y dot and z dot, y dot y cap and z dot z cap, because this is moving in the y and z plane. This is your speed. Now v cross b, b is given in the x cap direction, so the cross product will be x y z, 0 y dot z dot b 0 0 will give you b z dot y cap minus b y dot z cap. So this is your v cross b. Now just substitute the value in this equation, so we'll get force in this way, Q E z cap B z dot y cap, because this is your E, so electric field is in the z cap direction, that's why I have substituted here, and this is your V cross B. Now take the z component together and the y cap. So it will be, and you know force is given by m y double dot y cap and m z double dot z cap. This is the force, general formula for force. So we'll compare this force with this force. So compare the y cap terms and the z cap terms, so you will get my double dot as qb z dot and y double dot term as, means from here y double dot will be qb by m z dot, and we will substitute qb by m as omega. So this is your first equation. Now second, for the z cap, take the z cap common, it will be e minus by dot. So m z double dot will be equal to q e minus by dot. Now from here m will go this side and take the b common, it will give you this. Now qb by m we have substituted with omega. So this is your equation 2. Now we need to solve these equation 1 and 2. So these are two differential equations which we need to solve. So first to solve this, let's substitute the values. So if we take the third order derivative, y triple dot will give you z double dot, and we can substitute z double dot in this. Then we'll get a single equation that we have to solve. So let's take the derivative, will be y triple dot equal to w z double dot. Now substitute the z double dot value here. Now you have a single equation, and it is in the form of y triple dot and the y dot. So take the y dot as t dash, some other variable. So it will become t dash double dot, and it will be t dash. So take this side, now rearrange. You will get t double dot dash plus omega square t dash equal to omega square e by b. So this is some simple second order differential equation. As you can see, means it is something like y double dot plus omega square y equal to omega square e, means this is some constant. So that is this way you have the equation. So now you must use the differential equation formulas. So first we'll find the complementary function, then we'll find the particular integral. So for the complementary solution, put this lambda square plus omega square equal to 0, lambda will be plus minus I omega. Solution will be, complementary function will be c1 dash cos omega t plus c2 dash sin omega t. So solution will be in the cos and sine terms. If there was no iota, then solution will be in the exponential terms. So you must check the differential equation lectures to understand this if you don't know. So particular integral is nothing but, in this form we find 1 upon fd exponential ax. Fd is nothing but this d square plus omega square, and here exponential term, so it is exponential ax. And now you can see this, there you have no exponential term, means a is 0 here. So you need to solve this. So in place of a we will write 0, so d, in place of d we will write a, and a is 0, so it will be 1 upon omega square e by b. Omega square will cancel out, you will get e by b. So now the complete solution is the sum of complementary function and the particular integral. So add this to this will give you a total solution of the differential equation. So t dash will be this plus this. Now t dash is nothing but y dot. Now to find the yt, just integrate this. It will give you sin omega t by omega, cos omega minus cos omega t by omega, e by bt plus c3 some constant. Now substitute c1 dash by omega as c1 minus c2 dash by omega as c2, and these equations. So you will get your yt as this. Now you have your yt, but still there are some unknown constants. Now let's find for the zt also. We know wz dot is equal to y double dot from here. So we need to find the zt also, because we have yt but we don't have the zt. So that y dot is this. Find the second order derivative, will give you minus, means it will give you sin omega t by omega. Sorry, we need to find the differentiation. So y double dot will give you minus sin omega t omega. So it will be c1 dash omega sin omega t, c2 dash omega cos omega t. Now from here this omega will cancel out, so you will get z dot equal to this. Now integrating will give you z, so zt will be cos omega t by omega and sin omega t by omega, and here you will get some constant c4. Now we know c1 dash by omega as c1 and c2 by omega as c2, so you substitute them, so you will get zt. Now you have zt, you have yt, and you have the initial conditions. You know y dot and you know z dot. So substitute them, you will find c2 c3 equal to 0 and c1 equal to minus c4, that is minus e by omega b. So you have find all the values, just substitute for the zt and yt. So we'll get yt as e by omega b, omega t minus sin omega t, and zt as e by omega b, 1 minus cos omega t. So these are your solutions for yt and zt, that how y is changing with time and how z is changing with time. But still we don't know how the path, means to know the trajectory we have to find the relation between y and z. So that is the case. We need to find how z is changing with respect to y. So we need to just substitute each other, means in them. So how can you find the relation between y and t? So substitute e by omega b as r and square both sides, means this is y square z square, and find the relation. It will give you, means then take the sum, so it will give you something, means we will use this identity. Then it will be, in place of e by omega b we write r, so y minus r omega t square plus z minus r square equal to r square. After solving this you will get this equation. Now this is the relation between y and z, and also it involves the t. Now see, this is the equation of a circle where the center is r omega t r and x component is 0, so this will be your center. Now you can see that the center is depending on time, means center is moving with time in the straight line. So we have seen, and this is only the y component is moving. So we see that this motion is something like circle is moving. So I can represent you, this motion is something this way, means the center is moving with r omega t distance in the t time, and this particle is rotating with this. So when this is rotating and this circle is also moving, then you will get this kind of path. So that is the trajectory how we can define, means this trajectory, the cycloidal path we get when the circle is moving and the particle on that is also moving with the speed r omega. So that is the case. Now this represents a moving circle with center 0, r omega t and r. This will be the main center's coordinates. and radius r, with center moving in the y direction with speed v equal to omega r e by b. And in place of r, we will just substitute the value of e by omega b, and that will give you e by b as your velocity. So with this speed, the center is moving and in the y direction. So that's how we define the trajectory. So I hope it is clear to you now. Now let's see, this time E is parallel to B. First it was perpendicular, now E is parallel to B, and we just release the particle in rest. So see, you released, so it will move in the electric field direction, force will be in this direction, and no magnetic force because particle zero velocity. When it is moving, velocity in this direction, so V cross B, theta is 0, so it will get magnetic force is 0. So it will just move in this direction. Initial velocity is 0, and we take this as x direction, this is y direction. So in the x direction, motion will be in the straight line. So we can write just Vx, and the acceleration will be qe by m in the x direction. So Vx is nothing but ux plus axt, ux is 0, so it will be qe by mt. So that's how you define the motion in this. Now if you release with some velocity, initial velocity v naught, then in place of ux you will write v naught. So motion will be vx equal to v naught plus qe by mt. So that's how you define the motion of particle in the straight line, in the parallel to each other. Now if the particle is released perpendicular, moving perpendicular with the speed v naught to E and B. E and B are parallel, but particle is moving like this. So see, when the particle is moving like this, V cross B will give you a magnetic force which is in downward direction. So when particle is moving like this, it will it will feel a force in the downward direction. So it is something like move in a circle like this. Because of the magnetic force. But there is electric field also, so it will move something like this, means because of this. So it will be a helix. Now see, it is moving like this, but in the electric field direction there is an acceleration in the speed. So the pitch will change, means it will increase, pitch will increase because the speed is increasing. So you will get something like this. This will be your motion when it is moving perpendicular, and acceleration will be qe by m in the x direction. Initial velocity is 0, so vx is increasing this way. So in the same time it is revolving one circle, in the same time it will give you the pitch, and this speed is increasing with time. That's why vxt will increase. So that distance is increasing and pitch is increasing. So that's all in the motion of the charged particle in the electric and the magnetic field. In the next lecture we will start the magnetostatics, means in the constant current how the magnetic field works. So that's it for today. Thank you everyone.